Jupiter has radiation belts that would kill you in minutes. Saturn has winds that exceed 1,100 miles per hour. Mars has no magnetic field, almost no atmosphere, and surface temperatures that drop to negative 220 degrees Fahrenheit at the poles. These are dangerous places. They are not the most dangerous place in the solar system. The most dangerous planet in the solar system is the one closest to Earth, the one that looks the most like home. The outside, the one most people never think about. It is Venus. And right now, as you listen to this, it is doing things to itself that no other world in this solar system can match. The surface of Venus is 872 degrees Fahrenheit, every part of it, all the time. There is no cold side. There is no winter hemisphere. There is no relief at the poles. The temperature does not meaningfully change between the side facing the sun and the side facing away, even though a single day on Venus lasts 243 Earth days. The atmosphere is so thick and so efficient at trapping and distributing heat that the entire planet is locked at a temperature that would melt lead, melt zinc, melt tin, and glow a dull red if you could see the surface through the clouds. Mercury, which orbits 30 million miles closer to the sun, reaches about 800 degrees Fahrenheit on its sunlit side. Venus is hotter. Venus is farther from the sun and hotter than the planet that practically touches it. That should not be possible. It is possible because of the atmosphere. The atmosphere of Venus is 96.5% carbon dioxide. The remaining 3.5% is mostly nitrogen, with traces of sulfur dioxide and other gases. The total mass of this atmosphere is roughly 93 times the mass of Earth's atmosphere. Standing on the surface of Venus, you would experience an atmospheric pressure of 92 bar, the same pressure you would feel if you descended 3,300 feet into the ocean on Earth. No human body could survive it. Your lungs could not inflate. Your chest cavity would collapse. The pressure alone would kill you before the temperature did, and the temperature would kill you in seconds. For comparison, the deepest operational military submarine can survive to roughly 2,400 feet. The surface of Venus is deeper than that, measured in atmospheric equivalents. You would need a vehicle rated for a depth that exceeds the crush limit of most submarines just to exist on the surface for a few minutes. The Soviet Union understood this and sent machines anyway. Between 1961 and 1984, the Venera program launched a series of increasingly hardened probes into the Venusian atmosphere. The early ones were destroyed during descent. Later versions were armored like deep-sea vessels, with titanium pressure hulls, pre-cooled interiors, and systems designed to operate for as long as possible before the environment overwhelmed them. Venera 7, in 1970, became the first spacecraft to transmit data from the surface of another planet. It lasted 23 minutes. Venera 13 in 1982 survived 127 minutes, the longest any machine has ever functioned on the surface of Venus. It captured color photographs showing a barren, flat landscape of slabby rock under a dim, sulfur yellow sky. The light on the surface of Venus is roughly equivalent to a heavily overcast day on Earth. The sun is not visible. The clouds are too thick. The sky glows a uniform amber. And then Venera 13 was cooked, crushed, and dissolved. Above the surface, the atmosphere gets stranger. Between 30 and 50 miles up, the clouds begin. They are not water clouds. They are composed primarily of sulfuric acid droplets, concentrated enough to burn through metal, skin, and organic material on contact. The cloud layer is dense and extends for tens of miles vertically. Below the clouds, the air is clear but superheated. Above the clouds, the atmosphere thins into a haze of sulfur dioxide and ultraviolet absorbing particles that scientists have not fully identified. Something in the upper atmosphere of Venus is absorbing ultraviolet light in a pattern that does not match any known chemical compound. That unidentified absorber has been a mystery since the 1920s, and it remains unexplained today. The winds are one of the most disturbing features of the planet. At the surface, wind speeds are slow, roughly 2 to 5 miles per hour. But the atmosphere is so dense at that level that even a gentle breeze exerts the force of a slow-moving river current. Walking against the wind on the surface of Venus would feel like wading through waist-deep water. It would push against you, drag at your legs, and resist every step. Above the surface, the winds accelerate. At the cloud tops, 40 miles up, wind speeds reach 200 to 250 miles per hour. The atmosphere at that altitude rotates around the planet once every 4 Earth days. The planet itself takes 243 Earth days to complete a single rotation. This means the atmosphere is spinning roughly 60 times faster than the planet beneath it. This is called atmospheric superrotation, and it is one of the least understood phenomena in planetary science. No model fully explains why it happens. The atmosphere of Venus is moving faster than the ground, and the mechanism that maintains this differential is still debated. Venus also rotates backward. Every other planet in the solar system, with the partial exception of Uranus, which rotates on its side, spins in the same direction. It orbits the Sun. Venus does not. It rotates in the opposite direction so slowly that a single Venusian day is longer than a Venusian year. The planet completes one orbit around the Sun in 225 Earth days, but takes 243 Earth days to rotate once on its axis. If you could stand on the surface and somehow see through the clouds, the Sun would rise in the west, cross the sky over the course of about 117 Earth days, and set in the east. Nobody knows with certainty why Venus rotates backward. The leading hypotheses involve a massive collision early in the planet's history, or a long-term gravitational interaction between the dense atmosphere and the Sun's tidal forces that gradually slowed and reversed the rotation. Neither explanation has been confirmed. The planet has no magnetic field. Earth's magnetic field deflects the solar wind and protects the atmosphere from being stripped away by charged particles from the Sun. Venus has no such protection. Instead, it has what scientists call an induced magnetic field, a weak, temporary field generated by the interaction between the solar wind and the upper atmosphere. This provides minimal shielding. Over billions of years, the solar wind has been stripping hydrogen and other light elements from Venus's upper atmosphere, slowly removing any chance of water returning to the surface. Venus is not just inhospitable, it is actively becoming more inhospitable over time, losing the ingredients that could theoretically moderate its climate, one atom at a time, blown away by the Sun. And the surface is alive, not biologically, geologically. Radar images from NASA's Magellan spacecraft, which orbited Venus from 1990 to 1994, revealed a world covered in volcanic plains, shield volcanoes, lava channels, and pancake domes. The surface is young by geological standards, estimated to be only a few 100 million years old, compared to some regions of the Moon and Mars that are billions of years old. This means something erased the earlier surface entirely. The leading theory is catastrophic resurfacing, a period of massive planet-wide volcanic eruptions that buried the old crust under fresh lava. Whether this happened in a single event or gradually over millions of years is still debated. But the volcanism has not stopped. In 2023, researchers comparing Magellan radar images taken 8 months apart found a volcanic vent that had changed shape, with what appeared to be fresh lava flows extending downhill. Venus is erupting right now. The sulfuric acid clouds are being replenished by volcanic sulfur dioxide being pumped into the atmosphere from below. The atmosphere is not just a relic of the past. It is being actively maintained by a planet that is still geologically churning. This is what makes Venus more dangerous than Jupiter, more dangerous than Saturn, more dangerous than any other planet in this solar system. Jupiter will kill you with radiation. Saturn will kill you with wind. Mars will kill you slowly with cold and thin air. Venus kills you with everything at once. The heat melts your equipment. The pressure crushes your vehicle. The acid dissolves your surfaces. The atmosphere resists your movement. The volcanic surface reshapes itself beneath you. The planet has no magnetic field to shield you from solar radiation. And the environment is not decaying toward stability. It is being actively renewed by the volcanism below, fed by a greenhouse cycle that has been running out of control for hundreds of millions of years, with no mechanism to stop it. The longest any human technology has survived on the surface is 2 hours and 7 minutes. That was 4 decades ago. No spacecraft has returned since. NASA's Da Vinci mission, scheduled for the early 2030s, will drop a probe through the atmosphere to sample the chemistry on the way down. It is not designed to survive landing. It is designed to gather data during a 63-minute descent and transmit it before the surface destroys it. The probe will fall through each layer of the atmosphere in sequence, measuring temperature, pressure, wind speed, and chemical composition as it drops. In the upper cloud layer, it will sample the sulfuric acid droplets directly. Below the clouds, it will measure trace gases that could reveal whether Venus ever had liquid water, and if so, how long ago it lost it. And it will look for phosphine. In 2020, a team of astronomers announced the detection of phosphine in Venus's cloud layer. On Earth, phosphine is produced by anaerobic bacteria, organisms that live without oxygen in swamps, sewage, and the intestinal tracts of animals. There is no known non-biological process that can produce phosphine in the quantities detected on Venus under Venusian conditions. The implication was extraordinary. Something in the clouds of Venus might be alive. The detection was immediately challenged. Other teams reanalyzed the data and found the signal weaker than initially claimed. Some argued it could be sulfur dioxide misidentified as phosphine. The debate has not been resolved. If phosphine is real and is being produced biologically, then life would exist in the sulfuric acid clouds of the most hostile planet in the solar system, floating 30 miles above a surface that melts metal in an atmosphere of concentrated acid on a world that destroys every machine we send there. Da Vinci will not answer this question definitively. It will, however, collect the most detailed chemical profile of the Venusian atmosphere ever obtained. And that data will narrow the possibilities in a way that decades of telescope observations have not. That is the best we can do. Not land and explore, not send a rover. We will just fall through the atmosphere, measure what we can, and accept the loss of the machine at the bottom. Venus is 25 million miles from Earth at its closest approach. It is the nearest planet to us. It is almost exactly the same size. It has almost exactly the same gravity. And it is the single most hostile surface environment in the known solar system, more lethal per square foot than the surface of any gas giant, any ice moon, any asteroid. It is proof that distance from the sun does not determine habitability, that size does not determine safety, and that a planet with the same raw materials as Earth can become a place where nothing survives. If you want to keep exploring what the universe is really doing, subscribe, and I'll see you in the next one.